Hello, this is Otutochi Caleb Wadiba, and in this video we'll be solving a problem 1 of the recently concluded 2023 NMC diagram. So here I have given positive real numbers a, b, c, such that a plus b plus c is equal to 3. And I asked to prove that this expression here is greater than or equal to 7/12. So to do this, we'll start with simplifying things a little bit. It's looking a bit complicated, right? So we may have to break things down to be able to maybe see more clearly. So first of all, we can see that b raised to the power of 6 plus c raised to the power of 6 is equal to, of course, b squared cubed plus c squared cubed. Right, and then we can use the sum of cubes formula on this, right, to show that this is equal to b squared plus c squared times b squared all squared minus b squared c squared plus b squared plus c squared all squared. Of course, this is equal to b squared plus c squared times b raised to the power of 4 minus b squared c squared plus c raised to the power of 4. Right, then of course this is going to be equal to b squared plus c squared. Then we are going to bring out b squared plus c squared all squared here, so it will be something like this: b squared plus c squared all squared. So b squared plus c squared all squared is b raised to the power of 4 plus c raised to the power of 4 plus 2b squared c squared. So we'll have to, and we have minus b squared c squared here, so we'll have to subtract 3b squared c squared to make them equal. And this is what we have, right? So of course, this is going to be equal to b squared plus c squared times b squared plus c squared all squared minus, and this can be bc root 3 all squared, right? So then we are going to do a difference of squares on this, right? And we'll see how this goes, right? So this is b squared plus c squared times difference of squares gives us b squared plus c squared minus bc root 3 times b squared plus c squared plus bc root 3. Right, and we'll leave it at this for now. So but actually in the question, what we are working with, of course, this is without loss of generality, right? So it can be a raised to the power of 6. This will also go for c raised to the power of 6 plus a raised to the power of 6 and a raised to the power of 6 plus a raised to the power of 6. That similarly, those it will be the same for this second and third one as well. But let's start to simplify the first one first. So of course, what we actually have is cube roots of 4 raised to the power of 6 plus c raised to the power of 6. This is what we actually have, of course, plus 7bc. And of course it's in the denominator. But let's start with this. So this is equal to cube root of, we have already found a way to simplify b raised to the power of 6 plus c raised to the power of 6. So this is going to be equal to 4 times, we'll just put this here, b squared plus c squared times b squared plus c squared minus bc root 3 times b squared plus c squared plus BC root 3, right? And at this point, you are going to use a little bit of initiative, right? So you're going to use a little bit of initiative, right? This is going to be equal to cube root of b squared plus c squared times 2 times 2 plus root 3 times b squared plus c squared minus bc root 3 times 2 times 2 minus root 3 b squared plus c squared plus bc root 3. As we can see, they are both equal. It's still equal. Of course, we have b squared plus c squared, b squared plus c squared. We have this here and we have this here. But then 2 times 2, of course, is equal to 4. But then we brought in 2 plus root 3 and 2 minus root 3. That is going to help us in the next step. The plan is to use AMGM on this, right? And it's going to help us individually. Of course, this still changes nothing because 2 plus root 3 times 2 minus root 3 is equal to 1. Of course, when you do it, you get to difference of 2 squares. That would be 4 minus 3 is equal to 1. So this changes nothing. The reason of adding it is for it to help us in the first step. So we are planning to use AMGM. So of course, from AMGM that let me just do the 1 for 3. So the nth root or the cube root of x, y, z is less than or equal to the arithmetic mean, right? Something like this, right? So we have this, so the other way around, x plus y plus z over 3, that's the arithmetic mean, is greater than or equal to the geometric mean, which is the cube root of x, y, z. But we are already at this point, so we'll work with this, right? So if you are bringing that in, you'll get that this is less than or equal to b squared plus c squared plus 2 times 2 plus root 3 b squared plus c squared minus bc root 3 plus 2 times 2 minus root 3 b squared plus c squared plus bc root 3. And of course, this is going to be over 3. So we have that cube root of 4 b raised plus 6 plus 6 plus 6 is less than or equal to this. Next, we try to simplify. Next, we try to simplify that and see what we get. Right, so hmm. So we have b squared plus c squared we have b squared plus c squared, then this is going to be plus 4 plus 2 root 3 times b squared plus c squared minus bc root 3. And this is going to be plus 4 minus 2 root 3 times b squared plus c squared plus bc root 3. Of course, all over 3. Right? And this is going to be equal to b squared plus c squared plus, we have 4b squared. You can just simplify this quickly. So we have 4b squared plus 4c squared minus 4bc root 3. We can already see from here that some things will cancel out. Plus 2 root 3b squared plus 2 root 3c squared. Then 2 root 3 times root 3 give us 6, so that would be minus 6bc. Right, then of course we also have plus 4b squared again, plus 4c squared again. This time we have plus 4bc root 3, and then we have minus 2 root 3b squared. We also have minus 2 root 3c squared, and we'll have minus 6bc again. So this is still all over 3. So thankfully, all the terms with root 3 cancelled out, because if they didn't, that root 3 would have actually been a big problem. So thankfully they all cancelled out, and we'll be left with b squared. We'll have b squared plus 4b squared plus 4b squared to give us 9b squared. We'll have c squared plus 4c squared plus 4c squared to give us 9c squared. Then we have minus 12bc over 3, and this simplifies to 3b squared plus 3c squared minus 4bc. Right, so you can see that it's simplified rather too nicely. So that's one of the reasons for the initiative of bringing 2 plus root 3 and 2 minus root 3 into this. So it simplified very, very nicely. So from this, we can just draw the conclusion that cube root of 4 b raised to the power of 6 plus c raised to the power of 6 right, is less than or equal to 3b squared plus 3c squared minus 4bc. Right, and now we have something nice to work with, right? Remember that we still have 7bc here, so we can easily add that. So we can easily add that, and then we have cube root of 4 raised to the power of 6 plus 3 raised to the power of 6 plus 7bc is equal to 3b squared plus 3c squared, and then we have minus 4bc plus 7bc to give us 3bc, and it just keeps getting nicer. So next, so technically, let's call this expression p, right? Let's call it p, and we are trying to prove that p greater than or equal to 7 over 12, and we have already gotten a nice expression for the denominator here. So we'll just get that in. So of course, this implies that a over cube root of 4 b raised to the power of 6 plus c raised to the power of 6 plus 7bc. We are dividing by this, so if we use this, right? If we use this, it's going to become greater than or equal to, since we are dividing, and that will give us a over 3b squared plus 3c squared plus 3bc, right? And then of course this is going to be equal to, can as well just bring it mostly written by a and we'll have 3ab squared plus 3ac squared plus 3abc, right? And it's actually very nice. I remember I said that the same thing goes for B and the same thing goes for C. So technically we have B, which is the sum of all three, to be greater than or equal to a squared over 3ab squared plus 3ac squared plus 3abc plus b squared over 3bc squared plus 3ba squared, and again plus 3abc, then plus c squared over 3ca squared plus 3cb squared, and again plus 3abc. All right, and then we can use the almighty Cauchy-Schwarz on this, right? We have squares on top, and then we have nice denominators as well. So by Cauchy-Schwarz inequality, let me just put that here. So by Cauchy-Schwarz, we'll have that this is greater than or equal to a plus b plus c all squared over the sum of these three. So we can easily bring 3 out to give us 3 into brackets ab squared plus ac squared plus abc plus bc squared plus ba squared plus okay, abc adds together. So yeah, let's just put it plus abc plus ca squared plus cb squared and plus abc. So yeah, another thing you may notice at this point is that that denominator is actually equal to a plus b plus c times ab plus bc plus ca. So if we check it, let's a plus b plus c times ab plus bc plus ca is equal to a squared b plus abc plus ca squared plus b squared a plus b squared c plus abc plus abc again plus bc squared and plus c squared a. So if you check it, they are equal to each other: a squared b ac squared, b squared c b a squared c a squared c b squared plus 3abc. Alright, so we can simplify that. We can simplify that there. So just bring it here. So that will finally give us b over b is greater than or equal to a plus b plus c squared over 3 times a plus b plus c times ab plus bc plus ca. Now a plus b plus c can cancel with a plus b plus c, so that will give us b is greater than or equal to a plus b plus c over 3ab plus bc plus ca. Right? So now, right? So yeah, if you remember, a plus b plus c is equal to 3. So if you factor that in, so 3 cancel 3 to give us 1 over ab plus bc plus ca. Now remember that this is what we have as our P, right? The sum of these three. So now all we just need to show that P plus this, or we just need to show that P plus this is greater than or equal to 7/12. All right, now that's great. So also we found a nice way of simplifying this, right? Basically, we got that this is greater than or equal to 1/AB plus BC plus CA. So I think we may just be able to do the same thing for this and maybe work out a way of proving that their sum will be greater than or equal to 7/12. So let's do that. And another nice initiative we get is using the fact that cube root of A plus cube root of A plus cube root of A plus A squared plus A squared by AMGM is greater than or equal to their 5 times here, fifth root here. Fifth root of this cube root of A times cube root of A times cube root of A is A. Then times A squared is a raised to 5. And this is equal to 5A, right? So technically this implies that 3 cube roots of A plus 2A squared is greater than or equal to 5A. And that implies that 3 cube root of A is greater than or equal to 5A minus 2A squared. Now, similarly, we are also going to have that 3 cube root of B is greater than or equal to 5B minus 2B squared, and 3 cube root of C is greater than or equal to 5C minus 2C squared. All right, and we had in the second expression, not P, the one that P is added to, we'll have that we is cube root of A plus cube root of B plus cube root of C that is there, right? So we can easily add this and we get something nice. So we get that 3 cube root of A plus 3 cube root of B plus cube root of C is greater than or equal to 5A plus B plus C minus 2 times A squared plus B squared plus C squared. Now, of course, you know that 5A plus B plus C is 3, so this is equal to 15. Then minus 2. Then, of course, we also know that, I'm just show that here. We know that A plus B plus C all squared is equal to A squared plus B squared plus C squared plus 2AB plus 2BC and plus 2CA. So we can actually substitute A squared. So A squared plus B squared plus C squared is equal to A plus B plus C squared minus this guy here. Right, so we can do that here. We can put back to black. We can put A squared, sorry, A plus B plus C all squared here. All squared here minus 2AB plus BC plus CA. Right, and of course this A plus B plus C plus A plus B plus C is equal to 3, so that's gone. And you're basically left with AB plus BC plus CA here as the unknown, and which is very nice because for P we also got P in terms of AB plus BC plus CA here or something like that. So it seems we are like on the nice track, but let's continue. So we have this equal to 15 minus 2 times 3 squared is 9 minus 2AB plus BC plus CA, right? And this equal to 15 minus 18. Of course, this is 4AB plus BC plus CA. So with this we have 3 cube roots of A plus cube root of B plus cube root of C, right, is greater than or equal to 4AB plus BC plus CA. And then 15 minus 18 will give us minus 3. So in the question, you actually had cube root of A cube plus cube root of B plus cube root of C over 12. So we may want to bring out over 12 here. So to do that, of course, there's already 3 in the numerator. So you may want to just divide by 36. So let's divide by 36. And if we divide all 3 by 36, we'll end up with is 36. We'll end up with cube root of A plus cube root of B plus cube root of C over 3 over 36 is 12. 1 over 12, yeah, so 12. So greater than or equal to AB plus BC plus CA over 36. We have 9 minus 3 divided by 36. We have 1 over 12. So now we have this. This was the second expression, right? We have this greater than or equal to AB plus BC plus CA over 9 minus 1 over 12. So in total, or in entirety, everything we have is basically, so now we had this right at the beginning, this plus this, and we are showing that this first one, which is P, is greater than or equal to 1 over AB plus BC plus CA, and we are showing that the second one is greater than or equal to AB plus BC plus CA over 9 minus 1 over 12. So now if this is greater than or equal to that, and this is greater than or equal to this, then of course the entire thing has to be greater than or equal to their sum, right? So I'll just put that here. So we'll have A over, so this implies, of course, A over cube root of 4 raised square of 6 plus 0 square of 6 plus 7BC plus B over cube root of 4 times 0 square of 6 plus 0 square of 6 plus 7CA plus C over cube root of 4 times A raised square of 6 plus B raised square of 6 plus 7 AB. And the second expression we have cube root of A plus cube root of B plus cube root of C over 12. And now we have shown that this is greater than or equal to 1 over AB plus BC plus CA. And then this is greater than or equal to AB plus BC plus CA over 9 minus 1 over 12. Right? So, of course, so we can perform AMGM on these two, right? And think that's basically, so AB plus BC plus C will basically cancel out because that would be 2 square root of back to black. If you perform AMGM on those two, that would be 2 square roots of 1 over AB plus BC plus CA times AB plus BC plus CA over 9. And of course, we still have minus 1 over 12 left. So this cancels this. We are left with 1 over 9 under the square root. Square root of that is 1 over 3. So this will be equal to 2 over 3 minus 1 over 12. Of course, 2 over 3 is equal to 8 over 12. So we have 8 over 12 minus 1 over 12. And that gives us 7 over 12. Right? So we have been able to prove that this, I've been able to prove that this is greater than or equal to 7 over 12, which is what we are asked to do. So yes, thank you very much for staying through to the end, and stay tuned for the next video. Thank you.